So as you guys watched the notes last night, how are you feeling about it so far? Oh, it's okay. Could have felt worse, could have felt better maybe. Okay. Okay. Let's do example 6 before we do example 5, because as you can see, example 5 has the 7 with it, so it's kind of funky. We haven't done one like that before. See that? Okay. Let's go ahead and do example 6. So, what is the very first thing I should probably do? Yeah, find the vertex. Okay, so what's the vertex for example 6? -8. And then what was the other one? -3. Okay. All right, so we say I'm going to start writing my piecewise function. I guess I could go ahead and graph it. Oh my gosh, I really needed to pay attention when I made these notes. I made this so it was like you just almost can't even graph it on this graph. Left 8, that's like all the way over here. We're not even going to graph this one. We're just not going to graph this one, okay? Just scribble it out. We don't even need to graph it. Okay, so let's go ahead and do the left side. So we're going to say the negative version. And then we're going to start writing the equation out. So the equation happens to already be negative. So now I'm going to write, so I've got the negative version of -1/2 x plus 8 minus 3. Okay? If x is left. Are we cool with that? Negative version goes with left. Did we pick that up from the notes? That the negative version is when you go left, when you look at the left side? Okay. And then the regular version of the equation, yep, I am ready now. The regular version of the equation, I appreciate it. I'm helping you get your steps in. I don't know if you do that or not, but if you did. No? Okay. And then the regular version of the equation is if x is going to the right side. So negative version of the equation, left side. Regular version of the equation, right side. Does that make sense? I think that's the funkiest part of the whole lesson. So I am not saying that the equation is going to end up being negative, because it's not, is it? It's not going to end up being negative. But I am saying that I introduced a negative into the equation, and when I introduce the negative, that's the left side. Okay. So we're going to say if x is to the left of what number? -8, the x-coordinate of the vertex, because the x-coordinate of the vertex is where the absolute value graph switches directions. Okay? And then what else do I need to do here? One of them needs an equal to. It doesn't matter which one, I'm going to go ahead and put it on the top. Does not matter. I think to entertain myself, I alternated. I did top, then bottom, then top, then bottom, then top, then bottom, but it doesn't really matter. So if you wanted to be consistent and just always put it on the same one, that'd be fine. Yeah. Question, or is that a stretch?
Comment.
Yes, comment.
I don't know if you remember, but you said that I would never catch you making an error. And on the notes packet, the example 2, you missed your equal sign on one of the x's.
I did not. I did not. Oh no. Oh no. Miss Rice. But I mean, I had it here. Oh. I don't even know. I don't know what you're talking about. It's right here. It's right here. No, I don't know what you guys are talking about. It's clearly right here. No, I don't know what you guys are talking about. It's literally right here. You said example 2 didn't have an equal sign, and it's right there. You guys, crazy. Yes. Why didn't you take it before class? Okay, wait. You're gonna wait. I sure do. All right. What should I do now? Simplify it. What does a minus minus do? Makes a positive. Okay. So I'm going to take the 1/2 and distribute. I've got 1/2 x plus 4 minus 3. Okay. So what is my first equation going to be? Okay. Okay. All right, and then when I distribute the next one, I've got negative 1/2 x. Negative 1/2 times 8 is negative 4 minus 3. So what does that give me? Negative 1/2 x. Okay. If x is greater than negative 8. Okay. All right, now most of the time when we do the vertex, it's pretty easy. You just take whatever is inside the absolute value symbol and you do the opposite sign. And that has only worked because the x coordinate did not have a coefficient. That's the only reason it has worked, okay? So in problems like this, for you to find the x coordinate of the vertex, you have to take the 7x minus 2, and you have to set it equal to 0. This might remind you a little bit of factoring, if you guys remember factoring from Math 2 and from Math 1. This should remind you of factoring when you solved for factoring. Should be a little bit reminiscent of that. So what we're going to do is we're going to solve for x. So I'm going to take this, I'm going to add the 2 over because I'm trying to solve for x. So remember PEMDAS backwards. The first thing you do is you try to add or subtract something to the other side. Are you guys seeing how math is all connected? Like we go over something and then we just keep doing that same thing. 7x equals 2.
Like 5 years later.
I know. It just keeps being the same. And then we're going to divide the 7 over, because after we add or subtract stuff over to the other side, then we multiply or divide stuff over to the other side. So x equals 2/7. Okay, and then there was nothing on the end, so it's kind of like having a plus 0 on the end. So the process is still the same. We still would be like, okay, I need the vertex. Only for this one, instead of looking at it and being like, oh, the vertex is positive 2, which I think is what most of us would have naturally wanted to say, with this one, since it had that 7 there, we'd say the vertex is 2/7, and then the y-coordinate of the vertex is 0. So this does not happen on every problem today. There's like a couple problems it happens on. You just have to watch out for that little coefficient there. It happens every so often. You guys are like, oh, there's like problems around the room. We're going to get some exercise today. Yeah. All right, let's go ahead and start writing. So how do I start writing this piecewise function? How do I start writing the piecewise function? The negative version and the positive version. Okay, so I've got the negative version. And you can put the plus 0 on the end if you want to. You don't really need it, right? Because it's 0, so it's not going to do anything. If x is to the left, okay? And then we're going to have the positive version, which you can put the parentheses or not put them, it doesn't really matter, if x is to the right. Negative version, x is to the left. Positive version, x is to the right. Okay? And then what number do we put here with the x? 2/7. So we take the x-coordinate of the vertex, and that's what goes over there. 2/7, 2/7. Okay, what else do we need to do? We need an equal to on one of them. It doesn't matter which one. Okay. So the vertex was at 2/7, 0. That's going to be kind of hard to graph. 2/7, 0, something like this. It does not have a stretch or compression. So normally absolute value graphs go like over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. That's normal. And so this graph is going to do that. It's going to go over 1, up 1, over 1, up 1, over 1, up 1, each direction. So we're going to draw that as best we can. It's going to hurt my brain a little bit to do it. Over 1, up 1, over 1, up 1. Hi. Okay, so we've got just a little bit left to make it so that this is right, so that we're completely finished with this piecewise function. What do we need to do? Yeah, simplify it just a little bit. And it's mostly simplified already. It's just that top line, need to distribute the negative inside the parentheses. That's all we got to do. So I'm going to go ahead and just distribute the negative. So I get negative 7x plus 2 if x is less than 2/7. Positive 7x minus 2 if x is greater than or equal to 2/7. And then I'm done. Did you guys notice the theme of the Bitmojis? Because I felt real clever at 1 a.m. when I was putting these notes together. Anybody notice it's like a Taco Bell theme? Yeah, you like eat all the tacos and then you have bubble guts, you know? Nobody noticed the theme before I pointed it out? It was like, you ate all the tacos and then your belly? No? Nobody? That's like... But then, do you notice the rumbly guts afterwards? Oh. I thought it was very funny. At 1 a.m. when I was making this, I was like, ha ha ha, I'm hilarious. That was a good one, self. And I was like, okay. All right, there's the notes. So for the assignment, this is how it works. Are you ready? I'm not collecting these yet because you might need these to work on your assignment. Okay, so I'm not collecting these. So here's what I need from you. Everybody's going to start in a different place, okay? We're not all going to start on the same place because then you guys would be like a little herd of elephants, like going from one card to the next, right? We're not going to do that. So everybody's going to start on a different card, okay? So we're all going to get out a blank sheet of paper. We have learned that blank sheet of paper should probably not be in a spiral because we are going to turn this in, okay? And you don't want to have to turn in your whole spiral. So everyone get out a blank sheet of paper and write your name on the sheet of paper. You could probably do at least one problem, and then you at least know what you're doing, and you can ask a question. So get a blank sheet of paper. If you don't have paper, I've got lots of paper up here. See all that paper? It was donated. You can have some. Do a problem first, and then you can go take your medicine. All right, write your name. Marvelous. All right. So listen to the instructions first, okay? So on each paper, you can see there is a very large letter, all right? So you're going to see the absolute value equation. It says new equation. You're going to write down the absolute value equation, and then you're going to sit down, you're going to figure out what the piecewise function should be. And then you're going to look around the room to see where that piecewise function is, okay? So when you do the problems today, you are not numbering your problems. You are lettering your problems. Does that make sense? So maybe you start with problem D, maybe you start with problem H, maybe you start with problem whatever. I believe there are 11 problems total. I'm pretty sure there's 11. So you start with whatever problem, you write down the absolute value function, and then you start writing it as a piecewise function. When you're pretty sure you've got it right, you start looking for that. You can see that it says previous answer at the top of each of the pages. You start looking for that answer. When you find the answer, that is the card that you do next. Does that make sense? Nobody should be doing these in alphabetical order. If you are doing them in alphabetical order, you are getting them wrong, I promise you. Okay? They are not to be done in alphabetical order. If you are doing this correctly, every single person should be turning in their assignment with the letters done in the same order. Because the one problem leads you to the next problem, leads you to the next problem, leads you to the next problem. The reason I do activities like this is because you are checking your answers as you go. Does that make sense? You can't just do every single problem wrong because you'd never be able to get to the next problem. Okay? If you don't finish the assignment in class, then this activity is on Canvas so that you can do the rest of the problems on Canvas. Okay, there's 11 problems total. Any questions? Yeah. So it'll be like, I think, so we have a video tonight. I will hand out the video notes soon. And I want to say the video is like 13 minutes long. So we're going to have the video notes, and then we're going to make sure we can get these 11 problems done. Okay? Any questions? Make sense? Okay. So you can work in pairs. You can work independently. You can work however you want to. Go ahead and get a problem started. And then let me know if you need help.